All right, thanks everyone for coming to our session, which is going to be on running .NET and SQL Server inside of Linux on OpenShift. I'm John Osborne. This is Jason Dudash. We're the OpenShift experts for Red Hat Public Sector. With us, we have special guest star Harold Wong. He's the OpenShift and Azure expert from Microsoft. The ideas today for this 45 minutes that we've been allocated is to first, we're just going to level set with what .NET Core is and isn't compared to the .NET framework itself, how ASP.NET Core, how all those things work. So we'll give you a little bit of a slide-based crash course. But most of the actual time we'll be spending demoing and showing you, how things actually work with implementation. Jason's going to give you a quick crash course on how you actually spin up .NET apps on Linux using the CLI versus Visual Code, which is really cool. How you move those things across into containers. And then we'll get into more complex apps with SQL Server, running that on Linux. This is all really cool to me. This is my career coming full circle because 15 years ago when I was an intern, I actually worked on SQL Server and .NET, and then working in DoD, and then with Red Hat took a long layover, and now I'm back working with .NET and SQL Server again. So I'll have Harold kick it off, and he'll go through the first section. So.
All right, thanks, Ron. So as the Microsoft guy, I get to go through the slides. Right? So I have the most slides, and the rest of the guys will actually get to do the demos. So when you look at .NET, I don't know how many of you actually do .NET development. I'm guessing very few. But if you look at .NET, I saw a few hands go up. Hopefully you're not Microsoft people. But .NET Framework was really focused on the Windows platform, right? The entire Windows ecosystem. So you can do universal Windows platform apps. You can write everything because the CLR is distributed with Windows, right? But it's a Windows-centric type of a development environment. We changed that around a little bit. We came out with .NET Core, which is a subset, if you want to call it that, of .NET Framework. That is really targeted at the modern cloud experiences. So writing modern cloud apps, writing apps that are cross-platform. So you can use .NET Core to write apps for, build this out, for universal Windows apps, right? Desktop apps, you could write GUI-based apps, and you can also write apps that run on Windows, on Linux, and on a Mac. It's not just for Linux. But so the .NET Core is that cross-platform, very small, very lightweight, right? And then everything distributes with that. You don't have the DLL components and whatnot. But once again, if you see green, that's kind of like our little thing for Windows-based stuff. .NET Core is the cross-platform. And then we also bought Xamarin, which is also cross-platform as well, right? But if you look at the way we distribute things, Xamarin and .NET Core is probably very similar. And then when you look at the app models and the libraries, since .NET Framework is our historical, our legacy piece, we have a huge base class library. Kind of write apps for anything, do pretty much everything in that particular framework. If you look at Xamarin, the mono class library is essentially the same as the base class library, right? So you get the full library set. The middle one, which is the one we care about, the .NET Core component, has a much smaller core library. So the overlap is much smaller. If you're trying to take workloads that were written in .NET Framework and convert those to .NET Core, I can guarantee you your application from 10 years ago that you have 500 million thousand lines of code isn't going to just convert to .NET Core, right? All those class libraries are just not available. So there are still some challenges. If you're doing net new development, you're probably in good shape. If your .NET app was a simple app, you probably are in good shape. There is a tool that you can run that will analyze your code and give you an idea of what it would take to convert that over to .NET Core. And I want to point out Don, he's got a book back there, or he wrote a book, right? Go find him. He can talk about that as well, right? Kind of got to give the shout out. So what we're trying to do moving into tomorrow, right, into the future, is not have that weird, well, if you want to do .NET Core, it's a much smaller class library. We don't have a whole lot. That kind of sucks, right? That's not a good story. It's not a good solution. So we are moving towards the .NET Standard Library, where there's a standard library uniform across everything. So it's that one library that rules them all. And it doesn't matter what you're developing on. If you're doing .NET Framework or .NET Core or Xamarin, it doesn't matter, right? Because you are calling into a standard library. And so the future of that is the .NET Standard Library 2.0. I'm going to just say this now. I don't know when that's going to come out, but that's the future. That's where we're moving towards, and that's where we'll have better parity across all the .NET components in the Microsoft stack. In .NET Core, you can write your apps in C#, VB, and F#. So we do have support for more than just one language, right? Chinese, English, never mind. So this is just the slide that shows the innovation that we've done around .NET. We already know it's been open source, right? I'm sure you've heard that already. It is a runtime where we distribute it with the app. It is very fast. It's very small, hopefully. And it is really something that is targeted for the Docker development, right? Or for Docker deployments, for containerized deployments. Hence why, right, it's a great fit for running .NET Core app stuff in an OpenShift environment. Right? We distribute everything. You don't have to worry about DLLs. You don't have to worry about the CLR on the Microsoft side, and so forth. Now, if you were at the keynote just recently, if you really do want to run that huge .NET framework app in an OpenShift cluster, you know that's coming, right? That's what they showed, a Windows server in the same cluster as a Linux server. So you can do both. It doesn't really matter, although we hope you go to the smaller footprint, because that's really the way to go. ASP.NET Core, yes?
Just one question. Will it be only on Microsoft Azure, or will you have the possibility to do it as well on?
So question is, this mixed node of Windows servers and Linux servers in OpenShift, will it only be supported in Azure, or can you do that anywhere? Right? Yes, anywhere. It could be on-prem. It could be in one of the other cloud providers. It doesn't matter. The moment that's available, it's an OpenShift capability. Doesn't matter where you run it. All right, we prefer Azure. So ASP.NET Core, right, for writing those web-based applications, so taking the ASP.NET and porting that to .core as well. It is open in terms of the Microsoft platform is open. If you really want to use Visual Studio, the full Visual Studio, you can do Linux projects there. You can use Visual Studio Code, which is the free one that runs on Macs and runs on Linux and on Windows. We've got our Xamarin Studio. You can do CLI. If you're really a CLI guy, you can do that. From an IDE perspective, it really doesn't matter, right? If you really want to use Vim, do all your coding in Vim. I don't know anybody that does that anymore, but you could, right? So, Josh. So it is a first-class experience. That's what we're hoping that this is going to lead us to, right? And so ASP.NET, I already talked about this, being able to write those fast web-based applications in the .NET environment. So the very last thing, let me just build all this out. Quick summary, right? Cross-platform, open source. It is lightweight, so the packages are small. I won't steal the thunder from what Jason's going to talk about in terms of the packages. In terms of modern, it is modern. We do support C#. VB is not really modern, though, is it? But there's a lot of Microsoft-centric folks who really love VB, and they'll never let go of it. And also F#. It's very flexible, so it doesn't matter what platform you're running on. It does support your Windows, Linux, and Mac environment. You can reuse code. And it is fast. Now, right here, I need to go find the link where we have the performance test that shows that we were 8 times faster than Node.js and 3 times faster than Go, right? But we've done some testing. Hopefully, it'll be faster than .NET Framework, right? Depends on how you write all your code. And with that, I'm going to go ahead and skip past this one and turn it over to Jason.
Yeah, so Harold said it's not just for Linux, but it is for Linux. So let's take a look at how you would do that in Red Hat Enterprise Linux. It's actually really simple to get started as a developer to start building .NET apps. You basically enable the subscription to the channel where the RPMs are. You install with yum install, and then you just enable it. And we'll do a little demo of what that might look like for a developer. So I'm going to flip over to a terminal here, and I'll make a new directory. Say I'm going to make some cool app, right? Very interesting. And then the command line tool that Harold mentioned, right? .NET is the tool. So you take a look at all the things you can do there. We're going to build a new project, so we'll say .NET new. And I can even look at what kinds of projects I can build, because this is going to scaffold out a .NET app for me. And I have a number of choices. .NET Core is targeted towards a few different types of .NET workloads. One of them is web apps. Another is console apps. And the third is class libraries, right, if you want to build some sort of a dependency library. So if you, say, for instance, want to build a ASP.NET web app, we'll just say .NET new MVC. And it built it all. So if I look here in my folder, I've got all the scaffolding and the skeleton I'm going to need to start developing C# code to build a .NET web app. Pretty slick. But the really cool thing is, how do we do that in containers, right? I mean, .NET web apps are fun, but let's put them on OpenShift. That's what we really wanted to talk about today, is how do we containerize all that kind of stuff. So essentially, there's two different ways to do containers in .NET. The first option is you can use the Red Hat registry blessed image, our approved .NET Core 1.1 or 1.0 RHEL 7 image. And that could be your base container image. And then you could build your own Docker file, extend it, layer on all the things you want to do on top of that. The other option is S2I, which we're going to get into doing some more demos of. One thing that's, I'm going to show you real quick before I get into the S2I, though, the developer tool that Harold referenced in his slide deck, which is called Visual Studio Code. It's a lightweight version of Visual Studio that runs on Linux, it runs on Mac, it runs on Windows, right? So it's your cross-platform capable IDE. And so if I look at the stuff that was scaffolded for me here, it generated all these files, one of them being a project file. So there's a project.json file. And so this is really what enables me to so quickly pull in and run a web app in .NET, all the dependencies that it needs, right? The ASP core MVC stuff, how to do authentication with cookies. It's all the background dependencies that are required to do .NET development. And so there's a package manager called NuGet that all these things reside in, and they can get pulled down into your project from. So this is similar if you're familiar with, like, other package managers like NPM for Node.js, for example, where your packages, or or like Maven for Java development, right? That's out there. It's going to pull them in and get you everything that you need. So this actually a really nice IDE. I've been playing around with it lately a whole bunch. I wrote an extension over the weekend before I came out to Summit to plug it into OpenShift, and that was super straightforward. So it's easy to use and it's easy to extend. I'm actually a pretty big fan of it. I don't know if I told you that already, but so anyhow, let's look at how we can containerize something in OpenShift and how quickly I can build a containerized .NET app. So I'm going to flip to pop out all the slides here. So Harold stood up OpenShift on Azure for us for this week to do this demo. We're going to do a number of different demos. John's going to go through some stuff. I'm going to do a really simple demo right now of source to image on our OpenShift cluster that's sitting on top of Azure. So hopefully, have you guys gotten any info on OpenShift and pretty familiar with that from sessions earlier in the week? Okay. Maybe about 10% of the room. So I'll go slow and I'll explain some of the OpenShift things as I go through, maybe in a little bit more detail. OpenShift's organized in projects. And so right now I'm in just a demo project called Source to Image. And what I want to show is how I can easily add a web app that my developers can deploy out into a test-like environment, or something that's actually running in the cloud on the cluster. So I click Add to Project, and then get presented with this page of templates. These are quick starts, right? So it's a polyglot platform, so I can choose my language. Today we're talking about .NET. So I'm going to click the .NET template category, and I'm going to see all the different things I can choose from. So right here, .NET Core is what I want to do. I can actually choose the versions as well of .NET. It's kind of small on the screen there, isn't it? Let me zoom in a little bit. So it gives me this version picker, so I can target the specific version of .NET I want to deploy with. We're going to go with 1.1, which is the latest on RHEL. And I fill in just a few details about what my app's all about. So some cool app. And I fill in where the source code is. Because as a developer, I'm coming in, I don't want to know how containers work. I don't want to know how clustering works, how to use the cloud. I just want my source code to work, and I want people to be able to get to it. So as a developer, I know things like Git. I know things about where my source code lives and how it works. So I'm going to point to my Git repository that I know about. I'm going to reference the branch I want to deploy out of. And as a developer, that might be a feature branch, right? That might be I'm adding some new feature to my app. That's where it's at. I don't want to deploy an actual production version. As an ops guy, I might want to deploy off a version 1.8 tag or something like that. This is that box. This lets you do that. You can choose where out of Git what you're deploying lives. There's a bunch of advanced options. We're not going to go through them, but you can configure your routing, your security, additional capabilities about how much CPU limits it has. But at the end of the day, you're clicking just a few buttons, pointing to your source code, and now it's doing your build for you. It's going to wrap that build in a container, and you can watch it go through in this log. This has taken about 4 minutes now on this cluster that we put together. It'd probably go a little bit quicker if we provisioned like really big Azure background VMs, but we don't want to spend too much money for the demo.
Yeah, the slowness is because I deployed a small VM because I have to keep my costs down. Right.
Microsoft needs some business to Azure.
Buy more Azure.
Virtual machine.
Well, you can see in the log what it's pulling down those NuGet dependencies right now. The next thing it's going to do is package that up, bundle it into a container, and push it to your container registry and deploy it out. So while that's going on, I'm going to pop back to the slides here. And so the value behind that source-to-image capability is, in a nutshell, it's that developers don't have to worry about all the hard parts of how you containerize things. You want to make it as easy as possible for developers to get into the platform and use it. But then on the other side of it, operations has all this capability to manage and control your cluster, and those teams are working together out of the same space. So under the covers, how it works is there's that blessed Red Hat .NET image, and then you're layering your code onto the bottom of it, right? Developers do have the ability to configure some of that build process, some of that S2I capability, and I can show you that too. If I go to the source code for this app, there's a folder called .s2i. In there, we can set some environment variables. In this case, we've said we have extra, that's really small too, NPM dependencies of Bower and Gulp. For your web developer, those are things you're familiar with for sure. And I want to turn on .NET Publish. And that's a flag that tells .NET to bundle it all together so it's all prepackaged together when you deploy it out. There's also a custom run script in this example application so that we are doing a database update before we actually run the app. So those are some examples of the way that developers can use S2I and still extend it and modify it to do kind of advanced things. And I guess I'll show you the web console. This should be pushed by now. And if I go to the overview of the simple app, it's starting to deploy it. So I finished the build, and now it's deploying it out onto the cluster. I'll close the metrics. Oh no, it's still pushing to Docker. So one of the other cool things I can show you in OpenShift is the build itself happens in its own container, which is kind of like Inception if you think about it. But the build gets containerized, and as you're building the app, it gets containered. And then that container creates another container, which is the thing that's going to be deployed, the actual version that will be living in your registry as the app. So while this is going, do you want to?
If that's lagging, we can just jump into the SQL Server
Yeah,
stuff
let's
if you
jump
want.
into SQL.
Even though we are killing it on time right now. Yeah. Yeah. All right, cool. So thanks, Jason. I think that was a really good segue. Actually, I need you to drive. So I don't know how to use a Mac. We were supposed to use my laptop, but we're having trouble screen sharing, and I don't even know how to change screens in this thing. So, all right, can you go to the slides? Because I want to cover a couple of slides. All right. I know there's something with like 3 fingers. My wife's got a Mac, but it's like black magic to me. So, all right, cool. All right, so SQL Server. I'm just going to cover a couple things here before I show you it working. So, just a level set. So, containers are meant to be ephemeral, and that's great for like stateless applications. But when it comes to running something like a database in your application, you obviously need some sort of mechanism for persistent storage. So, if you're running, just plain Docker or in Kubernetes, there's a nomenclature of volumes, and what a volume really is a directory inside your container that doesn't share the life cycle of that container. So if the container goes away, spins up somewhere else, you have a volume that's stable and static that is not a shared fate that can be remounted to the new container. So inside OpenShift, we have this concept called persistent storage, where you can take the volume concept in Kubernetes and create persistence around that. So to map that to real storage that you would use in your data center, on-premise, might be like a NetApp or EMC device, something like that, or in the cloud using something like Azure storage. So there's essentially, I call this a static method. That might not be real, but that's how I call it. So there's essentially 2 ways to do this. There's the way in which an administrator creates persistent volumes, and then the developer, those persistent volumes contain connections to the actual storage devices with particular specs around them. And then the developer can go in when they create an application, they can say that, I need 5 gigs of storage. This one has, the main drawback to this is that everything is mapped 1-to-1. So if the admin goes and says, I need 20, or, here's a persistent volume of 20 gigs, and the developer says, I need 2 gigs, well, they get mapped 1-to-1, you're now using 20 gigs. So there's the newer versions of Kubernetes and OpenShift has this concept of dynamic provisioning. And what that is the developer says what they want, and then the storage mechanism actually takes that information and spins up the PV in real time. So and if you have a storage mechanism that's capable of talking to OpenShift and Kubernetes API, there's going to be a lot of them actually. Red Hat has one with Gluster. Azure storage can actually do this as well. So in the demo we're going to do, we're going to use the Azure storage to actually do dynamic provisioning and spin this up on the fly. So can you go back to the... Actually, do you just want to spin up go into the SQL Server project? And just spin up the SQL Server persistent template. I'm not even attempting this. This is like...
Is it imported already?
Yeah, it just type SQL S should pop up. Scroll down there. Just click on that one. And just change that to 2 gigs. 2GI, and then just change that to SQL Server, the database service name.
Just cut this out.
Yeah. And then I think that's it. Just scroll down. All right, spin that up. Harold, are you going to show the Azure, like kind of spinning this up in the back end, or okay?
Absolutely. So to prove that we're actually not doing smoke and mirrors, right? I've logged into the Azure portal here. How do I make it bigger?
Harold doesn't know how to use a Mac either.
I don't use a Mac either. Come on.
The only way this would be better is if I actually worked for Apple.
Thank you. At least I do understand some of the basic concepts of how to use a Mac. Not a whole lot. All right, so I've got this storage account called PV1 blah, blah, blah in there. And if we look in this storage account, I've got a container or a designation called blobs. And if I click into there, I have another container named VHDs. And in this container, you can see there are 2 VHD files, right? These are Azure disks. So I had defined a class of storage called generic, made it the default. So whenever OpenShift is asking for persistent volumes, we'll go ahead and just create a VHD in this storage account for that. So if you look, this one was, at 3:54 p.m., which is, about 20 seconds ago, right when that creation occurred for the storage account, right?
Cool.
So we'll go back to the OpenShift console.
Yeah. All right. Where's the button?
There's no button.
There's no button, sorry.
We should connect a mouse.
All right. It might take a second because it's waiting for the whole thing to spin up. So while it's doing that, I would like to just bring up a couple other important topics here.
Yeah, and
So-
I should point out, so real quick since we have time, what's going on is when Azure created that VHD, it created the VHD, 1 gig in size, it formats it, then it mounts it to the VM. So it attaches the disk to the VM, which then tells Kubernetes, which is really Kubernetes under the hood, and OpenShift grabs it, makes it available to the pod, but it has to format. So that takes just a minute or so or a few seconds before it becomes visible and presented.
If we had done the ephemeral storage option with no persistent storage, it would have spun up in a couple seconds. So another big topic for databases is initializing the database with data, and there's lots of different ways to do that. So I'm going to talk about some of the pros and cons just real quick, because this is always a topic that customers always ask me about. So the first, most basic way is, of course, you can just create an image with the data like baked into it. Now, that's not the greatest way to do it, of course, because it's just separation of concerns and all those things, but there might be specific small use cases, individual users, where you might actually want to do that. A second popular process is you might have like a CI/CD workflow with Jenkins, and then you might have Jenkins to do something like there's the MS SQL tools to inject data, like if you're using SQL Server. That might spin up inside of OpenShift. You might have a process where you use the OpenShift plugin for Jenkins. It kicks off the SQL Server database. And then based around your Jenkins build scripts might actually do something dynamically to provision the data. But of course, we're talking about OpenShift, so we have a lot of options to use containers as well. So the first is called pod Lifecycle Hooks, and this is something that would go into your deployment config. What this would do is essentially spin up another version of the container and run some specified command. So that might be running the tools, like MS SQL tools, which is what like the command line tooling is for SQL Server on Linux. And it might take some environment variables and inject, do a SQL injection that way to spin up like the test data that you want. You can also use init containers. Init containers are new to Kubernetes 1.4. And they're pretty cool. They're basically, it's like if you have a serialization for more like legacy apps where before my apps, this app starts, I need this container running. Before this container running, I need this one running. The only challenging thing about it is that it's totally serial. So once one app runs to completion, then it spins up the next one. So, but you can use this for initializing a database. You might have the init container reach out to somewhere to pull down data or pull down a script. Or even just do like a copy onto the database, especially if you're using a co-located container within the pods, because you can make them share the same file system or the same volume, and then you could just have one container that dynamically pulls through environment variables, connects out to some server or something like that, pulls in data. Jobs are really good as well because jobs are meant to be short-lived. They basically just run to completion. So you can have a job and you could create an OpenShift template around it, which has some variables that you set through the template, like, hey, I want this data set, and then it uses that environment variable for test one data, and then it goes out to get that, pulls it in. But once the job runs, it's just completed. Some of the drawbacks around these, except for jobs, is that a lot of them, when you use containers, is you're actually baking the runtime tools. You're baking those tools into the actual image that's going into prod. Most people don't mind doing that, but some people are, security focused or just, maybe they're just worried about the overall size of the image and they don't want to necessarily have, if it's a Java app, they don't want Maven in the container that's running in prod. And if it's a SQL Server app or a .NET app, they don't want SQL Server tooling around there. So there's a couple things. Microsoft, Docker, at the DockerCon a couple weeks ago, they released multistage builds. And what that is, essentially we had to copy artifacts into just a runtime container. With OpenShift, we've actually, most people don't realize this, but we've actually had this capability since OpenShift 3.0 a couple of years ago. And you can create a custom assembly run script as part of your runtime to do this as well, if that's something that you're interested in. If you go into the documentation, you just look for assembly run or extended builds. It's in the build section of the OpenShift docs. So, how do I? All right. All right. So right now we have the database running. I did want to show one more thing about the database itself, or just talk about one thing. Because the source to image for the front end actually takes about 5 minutes because all the NuGet dependencies and stuff, I'm just going to kick it off real quick as well, though. So I'll just kick this off for I don't like this no button thing. It's like weird. Yeah. All right. What is it? The 2 finger scroll. All right. All right. Yeah. All right. Yeah. So we're going to kick off this build. This is doing a Docker file build. But before I show you what that's doing, I just want to cover one last thing with SQL Server. So the SQL Server image that we used is actually something I put together myself based around the SQL Server bits that were tech preview for RHEL 7. There actually is an official image coming from Microsoft that's going to be available on registry.access.redhat.com. So that'll be like the official supported version. What I'm showing you now is more like a tech preview thing that I put together myself. And there's a couple things I want to mention about it. So here's the Docker file. I actually really like Visual Code. I'm actually dropping Atom for Visual Code on Linux, which is a pretty strong statement, but it is actually really cool. Even if you don't do .NET, you should check out Visual Code. It's pretty cool. So this is it's registering my Docker file as a plain text, but I can reassociate it as a Docker file. And what I really like about this is you can sync with Git and other things down here really easily. But a couple things to mention here. So you'll notice this container actually runs as systemd, because that's how SQL Server is installed on Linux. So there is debate about should you use systemd or not, but some apps really need systemd. So like one of the main benefits of using systemd is that it cleans up all the zombie processes for you. Which sometimes in databases that can be pretty important. So in this case, we're using systemd, and there's a couple things to note. So first, if you're running within systemd, if you send a Docker stop signal to a running container, what it's really doing is sending a Linux sigterm signal. Systemd doesn't catch Linux sigterm signals, so you have to send it a customized signal. So that's what this line's doing here. And then, of course, here I'm actually not starting a systemd service. I'm actually just starting systemd itself. And when I come back to the container, which is running, click here. I'm actually created a readiness probe. So a readiness probe within inside Kubernetes is something that you need to run and pass before the container actually accepts traffic. So if you've ever been within the console and you kick something off, and it says that it's running, but it says O of 1, like it's not ready to receive traffic yet, that's because it hasn't gone through the readiness probe yet. So the readiness probe is actually running the systemctl calls to make sure that that's active. And I also have a liveliness probe, too, to make sure that it's running on port 1433. So both those things need to pass before we accept traffic. So back to my application. So I think that's all I had about my application, or about the SQL Server itself. So we're still running here. See how we're doing. Good. So this will be just about done, actually, because it's going to skip the last layers because I've already done a build. But there's a couple things, other cool things I really wanted to mention about the .NET images, and Jason will show you something really cool, too. So this was the original Docker file I started with. It's 150 lines long. 150 lines long. Look at all these dependencies I needed, because this original app was built around Ubuntu. When I switched to the RHEL version, I was actually able to cut that down by about 1/3. The reason for that is because the .NET Core base image is super cool and brings in all those dependencies for you. And there's also a Red Hat, Jason, I don't know if you want to walk them through that, but there's a Red Hat container catalog now where you can go in and see what is actually in all the base images. You can check out the Docker files and the CVEs. All that's available through, what is it?
access.redhat.com/containers.
Yeah.
Yeah, this is a really cool thing that I knew was going on for a little while, but now, thanks to this week, I think we announced it and GA'd it, so we can talk about it. It's a container catalog that you can get to from access.redhat.com. And if, like John showed you, his Docker file, as a developer, remember I mentioned earlier, there's 2 different ways that you would containerize a .NET app, or any app that you were kind of trying to build that was from a core image. You'd use this registry.access.redhat.com from line at the top, right? And so you might be going, well, what's in that? And now you can go find out. So now you can go to this container catalog and search and say, what's in the .NET image? And here they are. So there's a lot of really useful information on the images that are provided by the Red Hat container catalog. if I click into one, I can see security vulnerabilities. I can see a timeline of tags that have been applied and patches that have been made to this image. I can see a health index. That's what these letters refer to, whether it's grade A, you're good to go, or F, it's got a ton of security vulnerabilities. Don't put that out on your cluster. It's really useful and interesting information. And it's done per version of each of these releases. So 1.1, I can see, has its own separate life cycle, separate from the 1.0 that we manage as well. Both of those, you can see 9 days ago, both got patched because both are being maintained. Pretty cool stuff.
Oh, can you show the Docker file?
Yeah.
'Cause I think that's really cool.
So if you get into a specific version of one of these, you can go in and see the Docker file. You can see the packages as well. So you can see all the packages that are part of that container. There's a ton here. I guess if I make the page say 100, there's a bunch. Those are all, and you can click on each one of these things and get more information about it. Like the bash shell, bin utils, things you'd expect to be in Linux. And then if I want to know how they built this image, here's the Docker file for it. Wow, that's really small there. So that's the actual Docker file that was used to build this .NET 1.1 image. And you can see
I use some of these as
labels.
reference too, like if I'm creating like my own images, just like the labels that the engineers at Red Hat created for Kubernetes and stuff. Like I'll kind of copy that and just modify it for my own. Like
cut and paste it
yeah,
in,
like
yeah.
totally.
Yeah. So yeah, it's really, really, really cool cataloging. So
Cool. Where was I? Oh, so using that, I was actually cut it down in about a third. Another cool thing was, I actually didn't know this existed, but has anyone ever heard of the dev toolset for RHEL? I actually didn't know this existed until like 6 months ago. But what this does is essentially allows you to deploy newer versions of things like GCC onto RHEL. So one of the packages I was installing actually required GCC 4.9, and 4.8 comes with RHEL 7. And when I was looking to do it manually, it was like running all these custom scripts. It was like a complete nightmare, and be up super late, to 3 in the morning hacking away. But I found this dev toolset, which was actually really cool, because then I could actually just do it in one command line, which saved me a ton of trouble and customized scripts and all sorts of things here. And this is showing as plain text too. So I'll just reassociate this as Docker file. This Mac. All right, there we go. As a Docker file. So yeah, so down here are the dev toolset. What is going on? All I had to do was basically do a yum install for that, and that was good. So that saved me a ton of time. Going back to the app. You'll notice that for both these, for the SQL Server and for the front-end app itself, I created what's called a template. So this is the app. It's pretty cool. It uses Angular and Node, and it uses .NET. .NET, what I really like about it, it's got this model view controller framework, which is pretty familiar if you used other MVC frameworks with Django or other Ruby on Rails. But it was pretty easy for me to actually kind of figure out and use it. We're doing a delete here. So this is the actual app itself. Once I log in, it's a shopping app. It's more of a reference app. I can go buy phones and TVs and stuff like that, and it's all pretty good. What else did I want to show? Oh yeah, we had the Visual Studio SQL Server extension, which allows me to connect right to the API, but it was on my laptop, which couldn't do the display. Yeah, so let's see. I thought there was one other.
Your store sells really expensive phones.
Yeah. Well, yeah, I think it does sell really expensive phones. Yeah. Yeah. No, that's I don't. Yeah. Yeah, that's about a 2-year agreement. So. So that'll build pretty good, and then if I do subsequent builds, I also used what's called, when I went to go run it, I used .NET Watch Run. What .NET Watch Run did is it allowed me to basically listen for changes. So even though this was all built inside OpenShift, this is more for, because I used Watch Run, that's more for development. I can go in, I could actually make changes right through the terminal, and I could make changes to the backend system and wouldn't have to necessarily worry if the .NET framework would pick up those changes in live. So I could do like live coding on the system there. And I think that's it. Do we have anything else? Yeah. Oh, we only have 5 minutes left. A lot of time. So yeah, so that's it. We're going to put all these slides online, and a lot of the links like to the actual code that we used and the templates that we used and the main Red Hat.NET page, all those things are going to be in the slide presentation as well. So I saw some people taking pictures of their phone, but we're going to put all these slides. You should be able to get them right through the Summit page. And you can even just Google it, but that's normally what I do. But worst case, you could also like tweet at me. But yeah, all this will be available, all the links and all the code and everything for you if you want to go play around with it. So
That's your takeaway message.
yeah.
Using .NET.
Honestly, yeah.
Like a jet ski for your
Yeah, and even if you're not using .NET, you should totally check out Visual Studio because it is really cool too. So, any questions?
Yeah, so great question. I knew that was going to get asked, right? Do we have a projected time frame for when .NET Standard Library 2.0 was going to come out? I don't know. The Microsoft Build conference is taking place next week, and so I'm waiting for all the announcements for next week. I'm hoping either it gets announced or they'll give us a better ETA on when that'll be available. So question was, when can you take a .NET application on Windows and move it into an OpenShift environment? I don't have an ETA on that, but I brought that up earlier, right, when I was talking. In our keynote demo just before this session, we showed an OpenShift cluster with both Linux and Windows hosts. We are actively working on that in the Kubernetes piece as well as in the OpenShift upstream. So
Did we put the in the resources? You mentioned the tool that there's a tool out there that can do basically an analysis of your application and see how .NET Core friendly it is. So did you put that in the resources?
We'll get that.
Okay. We can put that in the
I'll
resources
get
as well.
that to you before we
Yeah.
send out the
the
deck. But
yeah.
to do just core, the Windows stuff, it's not going to happen immediately, but know that it is coming. It's on the roadmap. And there is definitely an agreement between Microsoft and Red Hat to work on that to make that a sooner versus later thing, right? But what does sooner mean? I can't guarantee.
Yeah. I mean, and now it's probably a lot of greenfield apps and maybe basic apps that could be translated now. I think when .NET Core 2.0 comes out,
Yeah.
there'll be more you can move, and then the story will keep evolving. But the idea eventually is that everything will run. The .NET Core will be big enough that you could run like most everything cross-platform, right? That's the vision.
We
right?
hope.
So,
We hope.
oh, to do like a multi-cluster SQL Server deployment?
Repeat the question.
Yeah, so the question was, can you do like a multi-node SQL Server deployment? Probably not when the initial supported bits come out. In my instance, I have co-located the data in my app to do an inject, and it's using actually host storage. Like it's actually using a directory on the machine for persistent storage. Oh no, it's using the Azure storage and the one in the cloud. So.
I will
Yeah.
say that Travis Wright, who's one of the PMs on the SQL Server team, delivered a session, I believe it was yesterday. So go back and look at the recording of that. And he does talk about the challenges around HA for SQL in a container.
Yeah, there's a lot of challenges when you come to cluster databases. One thing I forgot to mention about SQL Server, though, is I don't know if any of you saw the benchmarks, but the SQL Server that runs in Red Hat Enterprise Linux is the fastest SQL Server at a 1 terabyte instance that, as far as any of the benchmarks go now. So that's the fastest SQL Server instance you'll get is running on RHEL. It is. I mean, there's the vision. There's what's now, which is greenfield apps in a single instance, and the vision, which is kind of getting everything to be cross-platform. And it's going to be an evolving story for sure.
And you have to keep in mind.
Oh, absolutely, absolutely.
But the thing to keep in mind about SQL Server is it evolved over how many years, built on a Windows platform with a lot of Windows reliance.
Yeah.
You can't just overnight take that and go, oh yeah, we're going to make everything available. It takes time.
Yeah.
It is coming.
Yeah. I mean, there's no reason if you're doing single instances, like actually, like Chuck said, you could use it for testing right now and go spin up instances, for apps, and you might have apps that don't need features, and you might have apps that cannot migrate yet. So Great. Well, thanks everyone for coming. I really appreciate it.